Hi there, this video is about the energy changes involved during the interconversion of states of matter in terms of kinetic particle theory. Let's get started. State changes, which are also called as physical state changes or phase changes, they are always reversible changes. Means these changes they proceed in both the forward as well as in backward direction. They proceed in forward as well as reverse or backward direction. Therefore, they are termed as the reversible changes. Now, whenever a phase change occurs, it involves change in heat energy or change in thermal energy. And the study of heat energy changes which occur during the phase change of matter, that is called energetics of phase change. Energetics is actually the study of energy changes during the phase change. Since the phase changes are reversible, so it means that solid can be converted into liquid on heating it, and liquid can be converted back to solid when it is cooled. Similarly, liquids can be converted into gases or gaseous state on heating, and when gases are cooled, they condense to liquid. So therefore, all these phase changes, they are reversible. Like all chemical reactions, phase changes also are accompanied by the heat energy change. Now let us look at what kind of heat energy changes occur when one physical state of matter is turned into another physical state of matter. We know that there are three physical states of matter: solid, liquid, and gas. Solid can be converted into liquid on heating it. Since the solid matter which is under discussion is being heated, it means that solid is absorbing heat energy to convert into liquid. So conversion of solid into liquid is an endothermic process. This term endothermic means absorption of heat energy, means heat is given in. Endo means in, and thermic is from therm, that stands for heat. Similarly, if liquid is converted into solid, it requires cooling, and while cooling a liquid, one is actually depriving the liquid of its heat energy. So therefore, during this process, system loses heat or releases heat. Therefore, such a process is exothermic process. Similarly, liquid can be converted into gas on heating it. Therefore, conversion of liquid to gas is an endothermic process because it requires heat energy. It requires heating of the liquid, and gas can be converted into liquid by cooling it. The process is called condensation. Therefore, condensation is an exothermic process, since gas cannot be converted into liquid until it is not deprived of its thermal energy or heat energy. Now, there are certain solids which do not enter the liquid state at ordinary pressure. Such solids they are called as subliming solids, and on heating such solids they directly convert into gaseous state. And similarly, if their vapors or gaseous state is cooled, the vapors deposit directly into solid. In either way, such solids they do not enter the liquid state. Such solids are called as subliming solids, and this conversion of solid into gas on heating without entering the liquid state, that is called as sublimation. That is called sublimation. And conversion of vapors directly to solid on cooling them without entering the liquid state, that is called solidification. Sometimes it is also called as sublimation too. So this solidification is exothermic process because it requires cooling of gaseous state or vapors of the solid to deposit them directly into the solid, whereas conversion of subliming solid to its vapors, it requires heating. Therefore, this process is endothermic process, means it requires absorption of heat energy or thermal energy. Now let us see what happens when solid turns into liquid. Actually, conversion of a solid into liquid on heating it at its melting point is called melting process, and conversion of liquid to solid, that's called freezing. Similarly, conversion of liquid to gas at its boiling point is called vaporization, and conversion of gas back to liquid is called condensation. We will define these terms later. Now let us see what happens to a state of matter when it is cooled or heated according to kinetic particle theory of matter. We know that kinetic energy of particles of any state of matter is directly proportional to absolute temperature. It is directly proportional to absolute temperature. Increase in absolute temperature increases the kinetic energy of particles and vice versa. Now let us see what happens when a physical state of matter is heated. On heating, what happens when the physical state, such as solid or liquid, is heated? Then what happens to these physical states, and why do they convert into other physical states? For example, solid turns into liquid on heating at its melting point, and liquid turns into its vapor state on heating at its boiling point. Now when these states of matter, they are heated, on heating their temperature rises. Similarly, kinetic energy of their particles, it also increases. As a result of this, molecular motion intensifies. As a result of that, attractions between the particles decrease or weaken, and consequently solid turns to liquid, and liquid state turns to gaseous state or vapors. Let us see it once again. When a solid is heated, its particles absorb heat energy. Temperature of the solid increases. Kinetic energy of its particles also increases. Because of this, the molecular motion intensifies and attractions between the particles weaken. When the solid is being provided continuously with heat, a temperature reaches at which the particles, they start vibrating at larger amplitudes, and hence they start leaving their mean positions. This is the temperature at which we say that solid is melting, and that temperature is called melting point. When amplitude of vibration of particles in a solid that increases beyond a certain limit, the particles of solid start leaving their mean positions, and hence solid starts melting. Now let us define what is melting. So melting is actually conversion of solid to liquid state. It is conversion of solid to liquid state when heated at its melting temperature. Melting temperature is also called as melting point. Now let us see what is a melting point. Melting point is the temperature at which a solid turns into liquid. That is called melting point. For example, melting point of ice is 0 degrees centigrade or 0 degrees Celsius. Now let us see what is boiling and boiling point. Boiling is the conversion of a liquid into its vapor state at its boiling point. Actually, liquid boils when its vapor pressure, when vapor pressure of liquid equalizes to atmospheric pressure, then the liquid starts boiling. Now let us see what is boiling point or boiling temperature. It's a temperature at which bubbles of vapor start forming. Bubbles of vapor start forming rapidly from inside the bulk of liquid. For example, boiling point of water liquid is 100 degrees Celsius. Now let us see what happens when we cool liquid or gaseous state of matter. So on cooling, temperature of a liquid or gas, it falls. As a result of that, kinetic energy of particles also falls. Because of that, motion of particles slows down, as a result of which attractions increase or dominate, means attractions are strengthened, and consequently liquid freezes to solid, and gas or vapor state that condenses to liquid. Now let us see, according to kinetic particle theory of matter, what happens when a liquid or gas is cooled. When a liquid is kept in a freezing mixture, in order to cool it, the liquid is deprived of its heat energy, as a result of which its temperature falls, and because of loss in thermal energy of the liquid, kinetic energy of its particles also decreases, and as a result of that, motion of its particles slows down, and correspondingly the attractions between particles strengthen, and as a result of which the liquid, it freezes to solid. Similarly, when a gas is subjected to cooling, its temperature falls, kinetic energy of molecules decreases, motion of particles or molecules slows down. As a result of that, attractions dominate, and ultimately on cooling, gas condenses to liquid. Now let us see the definitions of freezing and freezing point. Freezing is a conversion of liquid to solid at its melting point. Whereas freezing point is the temperature at which liquid converts into solid. If you liked the video, please do subscribe my channel and hit the bell icon so that upcoming video lecture on chemistry may not be missed. Sharing is requested too. Thanks for watching.